and see something about an essay?
Sure did. The Thanksgiving one?
And you were like, oh my gosh, what is this about? This is math class. We don't write in math class. Well, yes, we do. It's really easy. So I want to make sure we're all clear about how easy but thoughtful this assignment is. So, first of all, we should all be writing in every class. That's really hard in math, but we can do this essay. Secondly, I can't remember if I told you. Did I tell you I'm a certified English teacher, I'm an English major. So when I came to Cathedral, they had an English job and a math job, so I applied for both. I got the math job, so, and the rest, here I am. There was one year, they thought maybe I would teach an English class because they had like an opening, but it didn't come out, they didn't need me. But I love to write, and I proofread a lot of things that the school sends out. People will give me their things like Dr. Bridges' dissertation for his PhD. I proofread that. I love to do that. I'm a grammar fanatic. But I won't be when I grade your papers. I will mark corrections. So if you leave a comma out, and it's really easy to do. If you leave a comma out, I'll mark it. But I'm not going to take off points for it unless it's like 15 of them. Right? I mean, if you keep making these mistakes, that's just carelessness. So grammar, I am going to look at it. I'm going to read. I'm going to read every single word you write. This isn't something that's completion. I'm going to read it. I annotate. You all know what that means, right? So you will find, like, I will underline things. I will make little comments over here. That's not necessarily bad. That's keeping me on task and learning about you. Because what are you going to write about? You're going to pick a trait that you possess, that you are proud of, and you're going to write about that. So, for example, I am proud of being a good big sister. I believe I'm a good big sister because I do this, and I do this, and I do this. It's one page. By the time you explain what trait you're writing about and how you exemplify that, you fill that page. Now you can certainly write more than you want. MLA format, double spaced obviously. So one page, due in 6 weeks. Guys, seriously, 6 weeks, one page. You can do this. It's worth 25 points. 20 of them are the essay, 5 is turning it into turnitin.com. Okay, so you're gonna do that. Please, Don't write about being thankful for your mom. You should be thankful for your mom. And it's Thanksgiving time. We want to be thankful. You're not this is something you possess that you're thankful for. So I'm thankful because I'm a good listener. I'm thankful and proud of my leadership skills. Whatever you have that you want to talk about. So it's like bragging, but it's okay. It's okay to brag because you have this trait and you want to talk about it. All right, everybody understand what we're doing? Okay. It's about you. So unless somebody has already written about you, there should be no turnitin.com issues, right? Because this is authentic, original work. You don't need AI to write about you. I'm telling you right now, if those two things pop up, if I catch those two things, plagiarism or AI, which I consider plagiarism, it's a 0 and we're not talking about it. We're not discussing it, we're not rewriting it. I don't want any tears. Oh, Miss Ward, I didn't have time, so I did. No, you've got 6 weeks. As far as I'm concerned, I think I opened the Turnitin window on Friday. So anytime after Friday, you can turn this in. Get it done, right? Give you a chance to talk about yourself, get a few points for doing that, and I can learn about you. All right, we all good? If at any time as you're writing your essay you have a question, don't wait until the day it's due. Come and see me. Ask your question, get clarity, so that you can write this thing, get it turned in hard copy form. Don't email it to me. Hard copy. How tolerant do you think? 6 weeks, 1 page. How tolerant do you think I am of late? Not. Don't turn it in late. Don't waste my time or yours, right? Get the thing done. Don't wait until the day it's due to submit to turnitin.com. Because if you have Turnitin issues, I don't care. Turnitin issues need to be resolved right now, not the day the paper's due. Okay? All right, fun assignment. Can't wait to read them. It'll be fun. Okay, so now I need everybody to get out the new notes that I just handed out. And we're going to do a little bit of work with the new notes. And then I've got some review work because next Monday you're going to have a quiz over everything up through 111. So this is 112 that we're starting today, but we're not going to spend all period reviewing. But we're going to, yes, it'll be the last grade on the first quarter. Okay. All right. So I'm going through my notes. This is all things that you have learned before. So I am on the back side of the page. After we're going to do example 1. Okay? So you've got this picture drawn here. We've seen this picture before. And we're going to talk about the domain and the range of the picture. Now, when you do this, remember to watch out for arrows, right? Arrows? Because arrows means it keeps going. Notice that in this picture, there are dots on both sides. So we're going to stop and start this thing. What is the domain? Negative 5 to 5. Would everybody agree with that? What is our range? Negative 3 to 3. Everybody see that? Lowest points, negative 3, highest points, positive 3? Okay. Now, okay, so this is for f of x. This is for the regular function. Now we're going to mess with it a little bit. Now we're going to, g of x is 2 times f of x minus 1 plus 3. Now, this is, I need you to think back to last year. Does anybody know what any of these 3 numbers do in terms of the picture? You guys remember any of those numbers? You don't remember any of them?
Plus 3, the y-intercept.
Well, plus 3 isn't the y-intercept, but it impacts the y's because this moves everything up 3.
Oh, yeah.
That moves every point up 3. Okay, Drew?
The minus 1 moves it 1 right.
1 to the right. This is 1 to the right. Anybody remember what that guy does? Makes it twice as tall. It impacts the rise over running out, makes it twice as tall. So 2 times as tall. So in other words, if we're talking about tall, we're talking about multiplying y by 2. So this is going to multiply y times 2. If we're moving 1 right, we're going to add 1 to the x. And if we're moving up 3, we're going to take whatever we got over here and add 3 to it. Okay, so I want you to think about that for a second. What is that going to do to my domain? Because that's the next question. It says, what is the domain of this guy right here? So keep in mind, the domain started from negative 5 to 5. Only one of these numbers impacts the domain. Which one? That one? So if we're going to take everything 1 right, what's our new domain? Negative 4 to 6. Perfect. Every point goes 1 right. Okay, now my original range was -3 to 3. So if we times it by 2, if we take the height and stretch it, then it would be -6 to 6. But then additionally, we are moving it up 3. So we got it -6 to 6, but when we go up 3, our new range will be -3 to 9. You okay with that? All right, now, so on the original picture, we have the point, we're ready for problem B now. On the original picture, we have the point 4, 2. So 4, 2 is on the original picture. If we were going to draw this, what would happen to that particular point? Well, what happens to the x? Right one? So it's going to become 5. And what happens to the y? Well, the original gets doubled, so that would make it 4. And then it goes up 3, so that would make it 7. Is this starting to come back to you? You guys, I know you did a lot of this last year. Maybe it wasn't with weird shapes like this, but like with your absolute values and your parabolas, you move those along. All right. Find g of 0. Find g of 0. Now remember, this is the g function, right? So g of 0 is going to be 2 times f of -1 plus 3. Would you agree with that? Okay, so look at your picture. What's f of -1?
3.
3. So this right here is 3. 2 times 3 is 6. Plus 3 is 9. Now, we didn't actually have to work that out. I mean, it's good practice. I'm glad we did. But remember, with the original, we changed our range to this. And 9 was the highest point. Doesn't the highest point happen on the graph when x is -1? Yeah, so that makes sense. All right. How many solutions does the equation g of x equals 0 have? Explain your reasoning. Now, what are we looking for? When we say g of x equals 0, what would we be looking for? The zeros, where we cross the x-axis. So I know where the original crosses the x-axis, right? Let's see. What do you think? How many places? They're not asking me for where they are. They're just saying how many places does it cross?
It'd just be 1.
Why?
Because it moves it up 3. So would only cross at -4.
So the whole picture is going up 3, Kyle says. Let's look at that. So if I forget all the other changes, let's just move it up 3. Kyle says, but wait a minute, can I forget all the other changes? I doubled everything. Kyle. So that point that's down -3 is really gonna be down 6?
Yeah.
Does that make sense to you?
Yeah.
Now, if we think about that though, if we think about doubling everything just as it stands. Oh, this is really pathetic. But if I double everything as it stands, then this point is gonna be down at -4. This one's at -6. That one doesn't matter. This one's at -2. Okay. Now, if I move everything up 3, I think you're right, Kyle. I think that's the only place it crosses. Why did that bother me? Why am I not, what am I thinking of? I thought, explain to me again why you knew it was 1. Just because you moved everything up 3.
Yeah.
And that point would come up here.
Now the only place that it crosses
Yeah, but that point really doesn't come up there. This one, I mean, this is where I'm crossing now, so it's not the minimum point. But maybe that is a good enough reason. Does anybody have another thought on that? It doesn't move this point up above, Kyle. So what you're saying is it would look like this, it would be tangent, and it's not tangent. Do you see what I'm saying? You're saying if you take that picture and move it up 3, that valley is gonna be like this.
Yeah, but after you double it, so it depends on the.
Yeah, after you double it, it looks like this, right? So it does just cross once. So what would be a good explanation for that? I don't know, I just drew a picture. On the right side, everything's gonna be above, easily. And on the left side, the lowest point has to be connected to the next point, and it's got to cross in between there. I guess I just used my picture as an explanation, because I didn't come up with the words. Anybody have words for that? All right, we're going with the picture then. Okay, on what intervals is G increasing? On what intervals is G increasing? Remember, this is G right here. Did the changes we made, these changes right here, did they change the shape of the picture? I mean, the up and downness of the picture?
No.
Okay, so could we figure out the intervals that the original is increasing on and then adjust them? So what intervals is the original F? What intervals is he increasing on?
-4 to -1.
-4 to -1. Okay, anything else?
We have 1 to 4.
1 to 4, yep. Okay, so now G. Okay, what adjustments are we making? Our X's are going to move. So this is going to be -3 and 2. And our y's are gonna get doubled and add 3. So that would be -2, +1.
Miss,
Whoops, what?
if it's -4 to -1, aren't those both the x inputs? Aren't those both the x?
Thank you, Patrick. Thank you very much. So this part was right?
Yeah.
So what happens to that? It goes to, I was treating that like a point. Thank you. So that goes to 0. And this goes to 5. You're wonderful. Thank you so much, Patrick. Thank you. Those are not points. I was doing like I did that in the problem. These aren't points. These are intervals. All right, let's do a couple more here, and then we'll take a look at some review work. All right, so now we have the same picture, but now we have a new rule. So let's talk about what happens this time. All right, so here's the domain and range of the original. What is the domain and range of this one going to be? All right, well, let's talk about what changes that we made. What happened here? What's that do?
Double.
Not only doubles it, but also turns it upside down. So instead of the picture going up, like if you look at that point right there, instead of that point being up, it's going to be down. The whole picture is going to be upside down. So this is, we're multiplying y by -2. That will flip it and double it. What's this doing?
To the left.
Left 3, moving it, picking it up, moving it left 3. And what's that doing? Picking it up and moving it down 1. So, go back to your original domain and do all of that. Well, the x's, these are both x's, these are both x's. So what are we doing to our x's?
Moving it to the left.
Left 3. So our new domain is just going to be -8 to 8. How about -8 to 2? Left 3. Now how about our range? Well, we have to multiply it by -2. So that would be 6. And then subtract 1, so that would be 5. I'm going to write 5 here, but I may have to move that in a minute. Because this is going to be 3 times -2, which is -6. Down 1 is -7. And I got to have them in order. So does it make sense to you that when you flip the picture over, what was a maximum is now going to be a minimum? Yeah. So that's your range. All right. On what intervals is the graph of h concave up? So be careful. Be careful. The picture is f. This is what you're determining, what's concave up. Now, can you tell in F what's concave up? Can you tell in F what intervals are concave up?
Would it be like, you just switch it, right?
Could we say concave up would be -5 to -2 roughly?
Yeah.
And is there any other concave up?
1 to like 3.
Yeah, maybe 1 to 3. Or not 1 to 3, 0 to 3. Would you say that 0 to 3 maybe? I know we can fudge both sides, but can you live with 0 to 3? Whole numbers? All right, so that's F. So now H is going to be concave up where? Well, these are X values. And what's happening to our X's? Left 3. Wait a second. Wait a second. Didn't I turn my picture over? What does that change? When it was concave up before, it's now gonna be concave down. Is that a question? Nope. So let's look at the original to find out where it's concave down. Does that make sense to you guys? Okay, so let's look at the original. Concave down, this should be easy. -2 to 0. And 3 to 5. You okay with that? Guys, I don't even know what's happening. Concave down for F, because we're gonna tip our picture over, and if it was concave down, it will become concave up. So, what did we do to our X's? Left 3. So this will be -5, -3, and 0, 2. So that's tricky. We got to think about that for a second. Same thing for B, because we want to know where this is increasing. Won't that be increasing where this original was decreasing? Because if it was going down, think about something going down, when you flip it over, it's going to go up. So we need F to be decreasing. All right, where does that happen? Picture F, which is the picture we have, where is it decreasing? -5 to -4. -1 to 1, and 4 to 5. So where F is decreasing is going to be the intervals where H is increasing after you have moved them 3 units to the left. So this will be -8, -1, -4, -2, keep an eye on my arithmetic, 1 to 2.
Isn't it -8 to -7? From the
Oh, yes. Thank you, I don't know what I'd do without you guys, yes. Did I get the rest of them right? The rest of them right?
Yes.
All right. Now, find any solutions to the equation h of x equals 5. Okay, this is interesting. That means y is 5, right? So, can we think about this backwards at all? If my y is 5 in h, in this function, if y is 5, what did I do to get that y value? To get that y value, I moved it down 1 and multiplied it by -2. So if I work that backwards, the 5 would become a 6. And then the 6 would become a -3. Okay, let's make sure everybody's with us. This is the transformed function. So I'm trying to think about if the new value is 5 for y, what was the original y value before I moved it? So what did we come up with, Bryce? negative 3. Let's talk about that. What happens to that negative 3? It gets times by negative 2, and then drop down 1. So would a y value in the original end up at, a y value of negative 3 end up at 5 in the new picture?
Yes.
So let's look at the original picture. Are there any y values that are negative 3 in the original picture? Because those are going to become 5s in the new picture. Agreed? Okay, are there any of those? Look at, are there any y values that are negative 3? Yes. Now it says find any solutions. So there's one in the original picture. That point is negative 4, negative 3. If we transform that point by doing, this is the original, this is F. If we transform, then we're going to take our y, or excuse me, our x left 3, so it'll be negative 7. We're going to multiply that by negative 2 and go down 1, so it's 5. What are the solutions? There's only one, and it's where x is negative 7.
So our answer would be the corner points or where you
Find any solutions to this equation, x equals negative 7. All right, let's get example 4 done. So take a second, you and your partner, see if you can fill in the chart. This is all different now. This is not this picture anymore. See if you can fill in the chart for the original function and the transformed function. Uh-oh, here's one we haven't talked about yet. Does anybody, you know what this means? We talked about that. We talked about that. Anybody know what that does? That actually, that when you put a coefficient on x, it actually divides the x's. It divides the width. Okay, and I know that's a little bit crazy to think about, but you remember a minute ago when we had something like this? What did that do? I know it says x plus 3, but what did it do? It actually backed you up 3. So when you have something happening with x, it's always the opposite of what it looks like. So this looks like plus 3, but it's really minus 3. This looks like times 2, but it's really divided by 2. Okay? So this is going to squish your picture. Make it half as wide. All right. Go ahead. See what you can come up with. A couple more minutes. Let's see if we can fill them in.
Everything comes to life.
by 2 and 2. And then take y by negative 3. And then add a 5. Negative
So, divide by 2. You get 1. 1. Make it 3.
That's the original.
That is a big
This is 4. Yeah. And so 13 is the original. Divide the x by 2 because of this. So we got 2, and then multiply the y value by negative 5, and then up 5, I get negative 10. And then that value of negative 10.
You always get
But I can't
try to play it off to your
Like, what I'm doing is I'm dividing it by 3, and then after this, that's what I would do. But 5 times negative 3 plus 5 is 3. Does that make sense? Use this equation on this.
I could toss it.
Sorry, I thought you said
Look, these numbers are all going to go up. 0 times negative 2 is 0 plus 5 is 5.
I have to know. So out of place.
It's like,
Okay, anybody come up with any of them? Anybody come up with any of them? I heard some conversation. Bryce, I heard you talking. What were you talking about?
And when we functioned n of x, we got the, we were able to do in the last one.
Did you get, so you got one of
For
these
those
ones?
two,
You
yeah.
got these two, what did you say down here?
Negative 10.
For both of them?
No, negative 10 for the, yeah, and then negative 7.
Okay, so tell me how you did that. Let's focus on the negative 10. What did you do?
We took our original, which was 4, and then we divided that by 2, and then 2 times negative 3, and then added 5.
Okay, so wait a second.
Wait, no, wait. Wait, hold on.
You're finding n
Or
of
sorry,
2,
we took the
right?
original, which was 4.
So you're saying this number right here is gonna be n of 2? N of 2? So you said that's negative 3m of 4 plus 5?
Yeah.
Okay, so what's m of 4? We should have that. M of 4 is 5. And negative 10? And then she did the same thing for this one. So n of 4 this time, n of 4 is going to be negative 3 times m of 8 plus 5. And m of 8 we know is negative 12. Wait a second. How'd you get negative 7? Did I make another mistake here?
I think no,
I think we made the
I think
mistake.
I accidentally added, like, multiplied negative 3 by something else.
Bryce and his group said, my job, this number right here is n of 4. Okay? In other words, we are letting x be 4. So according to the rule, that's negative 3 times m of 8 plus 5. I don't know, I'm getting 41. That's what I got when I did it myself. It doesn't, I don't know what this looks like, but I'm getting negative 41. Does anybody see a mistake that I'm making?
I know what I did.
It's okay. It's all right. I've made 15 mistakes already, so it's fine. I'm not making another. Okay. All right, good. Anybody have an idea about these two up here? Bless you. Okay. Is somebody saying, how did I get something? Before I erase all this, what is the question?
How did you get negative 40?
Well, m of 8 is negative 12.
Wait,
M of 8
yeah,
is right here in my chart.
yeah.
M of 8 is negative 12. And I'm multiplying negative 3 times negative 12, and then adding 5. Because that's what the rule says.
I think you just may have rewritten it like as negative 41 instead of positive 41.
Oh, yeah, it's supposed to be positive 41. Was that your
Yeah,
question?
yeah.
Yeah. I got 41 right here, and then wrote it as negative 41. Of course I did. Okay? Alright, let's look at the others now. Let's look at the others now. Now our job is to find m of 0. That's our job. We're going to find m of 0. I don't have a rule for m. Well, what do I know about the relationship between the x's in the m function and the x's in the n function? They're not the same. They're not the same. Joe? What's the relationship between the number that goes here and the number that goes here? The m's are twice the n's, right? The m's are twice the n's. Now, when the number is 0, does it matter? No. So m of 0 is going to, well, m of 0, if this is m of 0, isn't that going to be still n of 0 over here? Aren't those x's going to match? If that's a 4, this one's going to have to be a 2.
Oh, yeah.
2. Because this function divides your x. This is double this. But since it's 0, it doesn't matter. Now, do I know n of 0? Do I have a value for n of 0? Negative 4. Subtracting 5. Dividing by negative 3. Isn't that the number that goes right here? Isn't that going to be m of 0? Guys, m of 0 is 3. Now I need to find m of 2. So think about this for a minute. M of 2. If this is a 2, then what's this going to be? A 1. So n of 1 is negative 3 m of 2 plus 5. I'm finding m of 2. So I'm making this be 2, which means this x is half of that, so it's 1. Do I know n of 1? Yes. So 0 equals negative 3 m of 2 plus 5. M of 1, or excuse me, n of 1 is 0. So n of 1 is 0. And so I'll subtract 5. And divide. So I got 5/3. Is that what you got? My arithmetic right? So m of 2 is 5/3. Now, don't be expecting a pattern or something. This is some weird thing like that shape we were using before. So it's not like cubing or, squaring or anything like that. Wow, that was fun. Okay, let me mark that down. And let me give you some review work for our final quiz of the quarter. I would love to do it, or actually, like, see you guys on Monday. Yours might be Tuesday. It's a long time next week, I see. I'm not sure how to that'll be Tuesday. I mean, ideally, I would do it Friday.
So far off.
Alright, so everybody has your review sheet. We will not have